These two posts are set to a 12-volt potential difference. Specifically, this one's at 12 volts and this one's at 0 volts. Now this voltage difference can be used to push electric current through wires and resistors, such as this light bulb. Now if I replace this single light bulb with a series of light bulbs, we'll observe less brightness, less current. I can even go so far as to replace it with a series of 3. And in that case, we'll have more resistance, less current. It might surprise you that you can wire multiple lines of current to the same 12 volts. Here, 3 lines of current are running in parallel across the 12 volts. I want you to notice that all the light bulbs are bright and all of them are connected directly to the voltage source. This is called wiring in parallel. So, is this violating some sort of physical law, the conservation of voltage? I mean, I can hook up as many resistors as you want to this 12 volts in parallel. No. There's no violation of any physical law. This thing is putting out a lot more power to keep up with the demand. In fact, if this was a battery, it would go dead a lot sooner. Most of the circuits in your house are wired in parallel. This allows you to turn off the light in the kitchen without turning off the fridge. You may not be familiar with that, but you are familiar with a surge control. A surge control is also wired in parallel. This allows you to plug in multiple devices at the same time without dimming out any of the other ones. In a series circuit, if you remove just one of the light bulbs, all the other ones will go out. Certain segments of these Christmas tree lights are wired in series. That is, if I take out one of them, a whole bunch will go out. The ones that didn't go out are wired in parallel. From experiments such as these, we get a better understanding of Ohm's Law. That is, the intensity of the current increases with the amount of voltage but decreases with the total amount of resistance in the circuit. In the case of series circuits, the total resistance is simply the sum R1 plus R2 plus R3, the total resistance. But in the parallel case, it was the currents that add. The total current is I1 plus I2 plus I3. Now substituting using Ohm's law gives this expression. Cancel through by the voltages, and you get the inverse sum rule for resistors in parallel.